Welcome. Today we will see problem number 4 on the root locus. Sketch the rough nature of the root locus of a certain control system with characteristic equation s cube plus 9s square plus ks plus k is equal to 0. Comment on the stability. Now this is the equation they have given. Therefore, solution: first convert given characteristic equation in the form of GSHS. Therefore, s cube plus 9s square plus ks plus k is equal to 0. This is the given equation. Therefore, s cube plus 9s square plus k into bracket s plus 1 is equal to 0. Divide by the group of terms which do not have k term with them, that is s cube plus 9s square plus k into bracket s plus 1 divided by s cube plus 9s square is equal to 0. We have to divide this whole equation by the term which does not contain k term. That's why we have divided it by s cube plus 9s square. Therefore, s cube plus 9s square divided by s cube plus 9s square plus k into bracket s plus 1 divided by s cube plus 9s square is equal to 0. Therefore, 1 plus k into bracket s plus 1 divided by s cube plus 9s square is equal to 0. Therefore, 1 plus k into bracket s plus 1 divided by, we have taken s square common, s square into bracket s plus 9 is equal to 0. Now, if we compare with 1 plus GHHS is equal to 0, we get GSHS is equal to k into bracket s plus 1 divided by s square into s plus 9. Therefore, this is our equation, final equation to draw the root locus. Therefore, next step, that is number of poles and zeros. Now for poles we have s square into bracket s plus 9 is equal to 0. Therefore, s square is equal to 0 or s is equal to s plus 9 is equal to 0. Therefore, s is equal to 0, comma 0 or s is equal to minus 9. Therefore, number of poles p is equal to 3. Now for zeros we have only one term is there in the numerator, that is s plus 1 is equal to 0. Therefore, s is equal to minus 1. Therefore, number of zeros z is equal to 1. Therefore, number of branches approaching or going to infinity n is equal to p minus z, which is equal to 3 minus 1 is equal to 2. Therefore, next we have to determine centroid. Step 3, centroid and angle of asymptotes. Centroid, sigma is equal to summation of real parts of poles minus summation of real parts of zeros divided by p minus z, which is equal to 0 minus 0 minus 9 minus of minus 1 divided by 3 minus 0, because we are having 3 poles 0, 0 and minus 9. Therefore, addition of is equal to 0 minus 0 minus 9 minus of, we are having only one pole, that is s 1 0, that is s is equal to minus 1. Therefore, substitute s is equal to minus 1 here divided by 3 minus 1, which is we are getting equal to minus 8 divided by 2 is equal to minus 4. Therefore, sigma is equal to minus 4. Locate that point on the x-axis. Sigma is equal to minus 4. Now, since n is equal to 2, we have to use only q is equal to 0 and q is equal to 1 to determine angle of asymptotes. Therefore, theta is equal to 2q plus 1 into 180 degree divided by p minus z. Therefore, theta 1 is equal to 2 into 0 plus 1 into 180 degree divided by 3 minus 1. Therefore, theta 1 is equal to 90 degree. And theta 2 is equal to, substitute q is equal to 1, 2 into 1 plus 1 into 180 degree divided by 3 minus 1. Therefore, theta 2 is equal to 270 degree. Therefore, plot these angles. Theta 1 is equal to 90 degree and theta 2 is equal to 270 degree through the centroid, that is minus 4. Now we will see root locus region and no root locus region also. We are having 2 poles at 0, that therefore 2 cross signs will be there at 0, and s is equal to minus 1, this is circle represents 0, and another pole is at s is equal to minus 9. Therefore, consider first of all this at 0 towards right side of this 0 number of p plus z is equal to 0, therefore towards right side of 0 we are having no root locus region. Similarly, consider minus 1 towards right side of minus 1. How many poles are there? 2. How many zeros? Z is equal to 0. Therefore p plus z is equal to 2 plus 0 is equal to 0. Sorry, is equal to 2. Therefore even number is there. Therefore towards right side of minus 1, no root locus region is there. Now consider minus 9. Towards right side of minus 9, how many p poles are there? P is equal to 2. How many zeros are there? 1. Z is equal to 1. Therefore p plus z is equal to 2 plus 1 is equal to 3. Therefore between minus 9 and minus 1, minus 9 and minus 1 root locus region exists. And beyond minus 9, no root locus region. Now, two angle of asymptotes we have to plot through minus 4. Theta 1 is equal to 90 degree and theta 2 is equal to 270 degree. X axis is real axis, y axis is imaginary axis. 0 plus j plus 2j, 0 minus j minus 2j. Now, to determine breakaway point, the characteristic equation is s cube plus 9 square plus ks plus k is equal to 0. That is k is equal to minus s cube minus 9 square divided by s plus 1, equation 1. Therefore differentiate k with respect to s and equate it to 0. Therefore dk by ds is equal to minus 3s square minus 18s into s plus 1 minus of into bracket 1 plus 0 into bracket minus s cube minus 9 square divided by s plus 1 bracket square is equal to 0. Therefore minus 3s cube minus 3s square minus 18s square minus 18s plus s cube plus 9 square is equal to 0. Therefore minus 2s cube minus 12s square minus 18s is equal to 0. Therefore s cube plus 6s square plus 9s is equal to 0. Therefore s into bracket s square plus 6s plus 9 is equal to 0. Therefore s is equal to 0 and s is equal to minus 6 plus minus square root of 36 minus 4 into 1 into 9 divided by 2 into 1. Therefore s is equal to minus 6 plus minus 0 divided by 2. Therefore s is equal to minus 3. Therefore two breakaway points 0 and minus 3. Always remember breakaway points lies in the root locus region. Therefore minus 3 is valid breakaway point because s is equal to 0, it lies in the no root locus region. S is equal to minus 3, it lies in the root locus region. Therefore s is equal to minus 3 is a valid breakaway point. Now intersection with imaginary axis, the characteristic equation is s cube plus 9 square plus ks plus k is equal to 0. By Routh's array, again we have to write like this: s cube s square s raised to 1 s raised to 0 1 k 0 1 k then 0 s square 9 k 0. Therefore s raised to 1 9k minus k divided by 9 0. Here s raised to 0 k will be there. From above array, 9k minus k means 8k divided by 9 is equal to 0. Therefore 8k is equal to 0. Therefore k is equal to 0. A system cannot work with k is equal to 0. So here it indicates that there is no intersection with imaginary axis. Now we have to plot root locus. Imaginary axis, real axis. Draw the poles. Indicate the value 0, minus 1, minus 9. Now root locus region exists between minus 9 to minus 1. Root locus region exists between minus 1 to minus 9, and this is minus 4 is centroid. Therefore locate the centroid. Draw the two angles, theta 1 is equal to 90 degree, theta 2 is equal to 180 degree. Now how the root locus will start? Root locus always start from the pole, always remember. Therefore root locus it will start from the pole like this, minus 9, and it is having two branches. This is the first branch, minus 1 to minus 9, or minus 9 to minus 1, it is the first branch. Now second branch it will start from 0. It will intersect this breakaway point minus 3 and it will go parallel to this 270 degree angle, and second branch will again start from 0 and it will cut the real axis at minus 3 and it will move parallel to theta 1 is equal to 90 degree. Therefore this is nothing but root locus, graph of root locus. Thank you very much.